Happy 2022, everybody. 2021 has been a weird year, especially that, the whole COVID is still going on. And then now eventually within late of the year, we now can get the Omicron variant. So make sure you get your booster shots, everybody. I also need to do that too eventually. Hopefully I can schedule it sometime soon. But anyway, to start off, let's actually do something starting off golden. So here we want to find the computation of sine of 9 degrees plus sine of 21 degrees plus sine of 39 degrees. And I said golden, so yes, the answer actually does have the golden ratio number. But let's actually find out exactly what is that computation value associated with that golden ratio. So this is actually just a typical standard like trigonometry problem. I know with these values of our arguments, it doesn't look like this is very, it's trivial to like think and understand, especially when you look at things more prospectively from a unit circle, from that perspective. So this is actually where things get a little bit trickier, but with the help of using some trigonometry identities, then we will hopefully get to where we want to achieve and figure out what the exact answer is with that golden ratio that I just mentioned. So anyways, nothing more that needs to be said, so let's start off 2022 the right way. So here's some notes that I want to just write down, or rather the formulas that we are going to be using to help find our exact computation over here. So let's first start off and say that the formula for sine of x plus sine of y is simply just equal to 2 times sine of x plus y divided by 2, then multiplied by cosine of x subtract y divided by 2. And then another thing I want to write, well, actually, for now, 2 more things I want to write, and then there's a couple more things I want to note as well, but we'll get to that when we get to it. So next, I'll write, we have a formula we'll be using. Obviously, this is a typical formula for the subtraction of 2 arguments of sine, and it's simply just equal to sine of x multiplied by cosine of y, subtract with cosine of x, and then multiply with sine of y. And of course, one more, you can't have this without the cosine as well of the subtraction of 2 arguments. Simply, this is just cosine of x times cosine of y, and subtract this with sine of x times sine of y. So we have our little formulas here, so let's actually manipulate the given above. So what we notice is that we have a sine 9 plus sine of 21. So we'll actually use this formula given here to actually rewrite it in this new form. And then what I'm going to do with the sine of 39 is I'm actually going to write this as a subtraction of 2 arguments of the degrees. So if you take a look at a closer inspection, what we can do is I'll let 9 be the x and 21 be the y for when we plug in this argument over here. So here we would have sine of 9 plus sine of 21. So the following we have is 2 times sine of 15 degrees multiplied with cosine of 6 degrees. And then for the sine of 39, I'll just write this as plus sine of 45 degrees subtract with 6 degrees. Now what we can see here is to further take this a little more further. I can also write 15 as a form of 2 subtractions of the arguments, but also using sine of 45 minus 6 degrees. That means we're going to be using this formula over here. So when plugging 45 and 6, of course 6 for y is going to stay the same, but we know that sine and cosine of 45 are actually both, in terms of radians, the square root of 2 divided by 2. So we'll actually just put this. So let's actually first put this as a form of subtraction of 2 arguments. So we have 2 times sine of 45 degrees subtract 30 degrees. Then this is multiplied by cosine of 6 degrees. Then plus sine of 45 minus 6, we just use this formula over here. And I said that both sine of 45 and cosine of 45 are both square root of 2 divided by 2s for the radians. So now this will be at plus square root of 2 divided by 2 cosine of 6 degrees. Then subtract with the square root of 2 divided by 2 sine of 6 degrees. So let's actually now evaluate this term over here. Well, yeah, this term right here. So going back, sine of 45 minus 30, we're using that same formula yet again. So this means, so when we evaluate this, so this is just multiplication, so I'll put the cosine of 6 first. So we have 2 times cosine of 6 degrees, then multiply with sine of, so we just plug this back in, 45 minus 30, so sine 45. So here we get the multiplication is that this is just the square root of 2 divided by 2, multiply with the square root of 3 divided by 2, subtract this with the square root of 2 divided by 2, and then multiply with 1/2. And so therefore we would get that this is just equal to 2 times cosine of 6 degrees, and then multiply with the square root of 6 divided by 4, and then subtract with the square root of 2 divided by 4. Okay, so we have this. So now let's actually just plug this back in. So I'm just rewriting the same thing again with our new evaluated of the, of the bracket right here. So here we have, okay, so writing the same thing again, 2 cosine 6 degrees, multiply with the square root of 6 divided by 4, minus square root of 2 divided by 4, then add this with the square root of 2 divided by 2 cosine of 6 degrees, and then subtract the square root of 2 divided by 2 sine of 6 degrees. So what you'll notice is we can actually distribute the 2 times cosine of 6 into the what's in the parentheses. But what you'll notice is that if I were to distribute 2 cosine of 6 degrees into here, so that would be the square root of 2 divided by 2 cosine square root of 6, then the terms will cancel each other out. So you're left with just having to evaluate, distribute the 2 cosine of 6 into the square root of 6 divided by 4, but then we have to subtract with this argument right here. So now, we'll just repeat this again. These two, if you distribute 2 cosine of 6 to here, and it'll cancel with this term right here. So we only have 2 terms left to evaluate. And this is where a lot of things are going to get, we have a couple more formulas that we're going to be using. And there's a clever trick that we're actually going to be using as well eventually. So the square root of 2, we'll just evaluate, distribute the 2 into here, so this will be divided by 2. Then cosine of 6 degrees. Then we subtract this with the square root of 2 divided by 2, and then times sine of 6 degrees. Then what you'll notice is, this is where the fun part gets interesting. What I can do is I'll factor out a square root of 2 to both sides. So this is the square root of 2. Then from here we'll be left with the square root of 3 divided by 2 cosine of 6. Then subtract with 1/2 times sine of 6 degrees. Then you'll actually notice something interesting, and that we're actually doing something a little bit backwards, going back to the formula we just did earlier, except you'll notice that the square root of 3 divided by 2 is also another way of putting it as the cosine, or rather, no, I was right, it's a cosine. This is going to be the cosine of 330 degrees, and then over here, negative 1/2 is the same thing as sine of 330 degrees. So we're taking a step backwards, going in the opposite direction and rewriting it back to the formula from the left-hand side from here. So cosine, cosine. So we're actually using cosine of x minus y in this discussion, and that means we're actually taking the subtraction of 2 arguments. So in other words, we can rewrite this as, so I'll put this over here to the next, keep going forward. So this is the square root of 2 multiplied by cosine of 330 degrees subtract 6 degrees. In other words, this is the square root of 2 times cosine of 324 degrees. And in other words, we can actually keep going and write this in a form of adding the arguments. So here we have cosine, so I'm actually going to put down another fact that we're going to be using, rather another formula, and that says cosine of x plus y is just equal to cosine of x times cosine of y, then subtract with sine of x, then times sine of y. And so we'll just use this to our for our argument right here. What we can do is, I can actually write this as the square root of 2, then we'll put this as a sum of two arguments. So I can write this as 270 degrees, add this with 54 degrees. Then we can actually use this the formula I just wrote here, and write this as the square root of 2 multiplied with cosine of
270 degrees, then what is it, times cosine of 6 degrees, subtract sine of 270 degrees, then times sine of 6 degrees. Then what you'll notice is that cosine of 270 is actually just going to equal 0, and while sine of 270 degrees is just equal to -1. And so therefore, this term will just vanish, while this one will just become positive. And so therefore we have the square root of, well, actually this is supposed to be 54, sorry about that. I'm writing so many sixes, that's why I got that stuck in my head. This will be 0, and then this will be the positive, so the negative, negative, so positive. So then we're just left with the square root of 2 times sine of 54 degrees. And now we have another formula that we're going to be using yet again. I know, so many formulas that we're going to be using. Well, that's the beauty of trigonometry. So another thing we're going to be using is the following formula. So we actually can write, so 2 more formulas actually, as a matter of fact. So we can actually write the following. So we have sine of theta, for example. It can be rewritten as cosine of pi over 2, or rather we can say that 90 degrees in this sense, subtract theta. And then another fact that we're going to be using is the fact that cosine of 2 theta is actually just equal to 1 subtract 2 times sine square of theta. So we'll eventually use this formula in just a sec, but for the first part, that means sine of 54 degrees can actually be rewritten as the square root of 2 times cosine. So this is 90, subtract with this argument, so cosine of 36 degrees. Now we'll just replace the cosine of 36 with this formula over here. So now square root of 2, then times cosine of 36 degrees. We can write this as a double, so the theta in this example here, this will be 18. So rather, in other words, I can write this as the square root of 2 times 1 subtract 2 times sine square of 18 degrees. And then sine of 18 degrees is actually going to equal, so it actually equals a special number, which I'm not really going to go over that proof. Instead, I'll leave that as an exercise for you guys to verify. Sine square of 18 degrees is actually just equal to the square root of 5, subtract 1, and then divided by 4. So I'll just replace this back into here. So now square root of 2 times 1 subtract 2 times the square root of 5 subtract 1 divided by 4 square. Then if you just do a little bit of simplification in algebra, we're going to get that this is just the square root of 2, then times 1 subtract, so this will be 6. This is just multiplying the 2 afterwards, so 6 minus 2 times square root of 5 divided by 8. Then we keep going further, we could say that this is the square root of 2 times 2 plus 2 times square root of 5, then divided by 8. Then you can write this as the square root of 2 times 1 plus the square root of 5 divided by 4, which is just simply just canceling. And then in other words, you can factor out the square root of 2. Then this will be, in other words, 1 plus the square root of 5 divided by 2. But notice that 1 plus square root of 5 divided by 2 is actually equal to the golden ratio. So I'll just replace this with lowercase phi. And if you want to, you can actually write this as another way of saying the final answer is either the square root of 2 times phi divided by 2, or simply phi divided by the square root of 2. And so there we have it, the final answer in the orange box. And just like that, this answer to our computation is indeed golden in one way or another. So yeah, that's I really want to choose this problem, do this problem simply because of the fact, like, you know, the whole idea with, you know, 2021 being, you know, things is just getting out of control, especially with this whole, you know, pandemic. And I hope that really 2022 will be the start of a year where, you know, change is better, and of course it is better. So let's actually make 2022, you know, the best of it, and hopefully we can actually beat this variant / pandemic. So yeah, that's pretty cool if you ask me.